This video is going to cover a lot of the foundational basics as far as your understanding of what their purpose are, and in addition to that, you're going to go through a lot of vocabulary to make sure that you understand the terminology used in chemistry when we're talking about forming ions and molecules. So, the purpose of making ions and molecules: elements combine together using law of definite proportions to create this thing called stability. So, all elements are seeking stability. Because they don't have stability, then they're going to attempt to form ions and molecules. Stability is the sum of all charges are equal to 0, or when all charges are equal to 0, then you have stability. The exceptions to these rules include the noble gases, which are group 18 on the periodic table, the diatomic molecules, which include hydrogen, nitrogen, fluorine, iodine, chlorine, and bromine. And this is only when these elements are bonded with themselves are they a part of the exception. So, starting with our vocabulary, groups or families are vertical columns on the periodic table. There are 18 total. Group 1 are your alkali metals. Group 2 is known as your alkaline earth metals. Group 3 through 12 are your transition metals. Group 13 is boron family. Group 14 is carbon family. Group 15 is your nitrogen family. Group 16 is oxygen family. Group 17, the halogen family. And Group 18 are your noble gases. And remember, the noble gases are already stable, so they're not going to form any ions, or they're not going to bond with anything else to form molecules. Continuing our vocabulary, the octet rule. The octet rule states that when an element will lose, gain, or share electrons in order to produce stability. So remember, all elements are seeking to reach stability. The octet rule is a way to demonstrate how these elements are going to get to stability. So either they're going to lose, gain, or share electrons. So if you reflect back to your notes when we talked about chemical bonding, you should remember that we talked about hydrogen bonds, metallic bonds, covalent bonds, and we also talked about ionic bonds. So when you're talking about a lose or a gain, you're actually referring to the ionic bonds. So there's a transfer of electrons. This transfer may be a gain for one element, but it may be a loss of electrons for a second element. So when you're talking about sharing electrons, that's your covalent bonds. When you're talking about covalent bonds, there's two types. You have your you have polar covalent bonds. Polar covalent bonds is when there's an unequal sharing of electrons, and then you have non-polar covalent bonds, which is when you have an equal sharing of electrons. So remember, all of your bonds are seeking stability or creating stability for your elements who are not stable. And remember, the elements that are not stable need the stability so that they're not dangerous, they're able to be used. Your noble gases and your diatomic molecules won't be a part of this. An ion is a charged particle. There are multiple types of charged particles, or multiple types of ions. This includes the cation, which is a positively charged particle, an anion, which is a negatively charged particle. Then you have monoatomic ions. These are formed from one type of ion. They are formed from one type of atom. So the examples here include Fe, which is iron. Iron has a 2+ charge. You have Pb. Pb has a 4+ charge. Remember, these are transition metals. That's why they're in green. Your transition metals are charges that you'll have to remember, but they are on the polyatomic ion sheet that I gave you. Chlorine is in this brown color because chlorine is a halogen. Chlorine has a negative charge here. Remember, if you don't see a number beside your negative or positive charge, that means that there's an understood 1 there. So chlorine has a -1 charge. Nitrogen here in orange has a 3- charge. So soon you're going to find out how the octet rule is calculated in order to determine the charge for this nitrogen. Polyatomic ions are formed from many atoms. So the same sheet that you have the information about your monatomic ions, you also have your polyatomic ions. So notice that the polyatomic ion here has nitrogen and hydrogen. It has 4 hydrogens specifically. So your nitrogen and your hydrogen, or your 4 hydrogen, form this polyatomic ion called ammonia. So here you have your NO2 minus, so nitrogen, oxygen. This is actually missing your charge here, so this could have been a nitrate or this could have been a nitrite. One is NO2 minus and the other one is NO3 minus. So here you have a carbonate, which is your carbon, oxygen. You have 3 oxygen here. Together they have a 2 minus charge. So a carbonate is formed from 1 carbon and 3 oxygen. So finishing up our vocabulary, you have a compound. We've talked about compounds before when we first learned how to classify matter. This should be a review for you. A compound is a substance formed by 2 or more atoms. You have more than one type of compound. Your types of compounds include binary compounds. So we all know that bi means 2. Think about a bicycle. If you're riding a bicycle, your bicycle has 2 wheels. Binary compounds are composed of 2 types of atoms. The examples given here include NaCl, so it means you have 1 alkali metal and a halogen. They form together to give you sodium chloride. Here you have 2 hydrogens and 1 oxygen. They form together to produce water. Ternary compounds are composed of 3 types of atoms. The example given here, you have sodium, nitrogen, and 3 oxygen. NO3 is a polyatomic ion. Together this is sodium nitrate. Here you have aluminum, phosphorus, and 4 oxygen. This actually forms aluminum phosphate. Then with the tertiary compounds, they're composed of 4 types of atoms. So you have your ammonia and you have nitrate. So this is ammonium nitrate. So when you watch the next video, you're going to be able to apply this information and learn how to write the chemical formulas for monatomic and polyatomic ions.